Hello, welcome back. Let's continue where we left off. So, we were in our app bluenrg.c file when we decided to create our printf. Okay, because we want to use printf here as well, I'm going to include stdio.h. This is actually where we really want to use printf. I'll say include over here stdio.h. Okay, so this is it. So I'm going to start off by creating a local variable here known as BLE status. So I'll say tble status, and this will hold a return value ret. And this here is defined. So if you see, this is the same as uint8 underscore t. So this is defined for us to make the code more readable. Uint8 is given another name known as tble status. Okay, so that is it. And also I'm going to create a variable here for our, let's say, an array to hold our device ID. So I'll say uint8 underscore t, and then I'll say server bd address, our device address rather. And over here I can simply give it a simple address, like I can say 0x 0x01 0x 02 03 04 05 06. Okay, so whenever we want to change our device address, we change this value here. Okay, so then I'm going to come down here and create a local array here. I'll say over here uint8 underscore t bd, like this, meaning Bluetooth device address, just like we created. It has the same name here. And then the size is going to be the size of, we can give it a size of 6, or better still, we can create a symbolic name to hold this. So I'll come over here and create a symbolic name. I'll say define over here bdaddr underscore size, and the value of this is 6. Okay, so we're gonna pass this to the array. Okay, so what we want to do then is copy this value into this value, right? The reason we're keeping this is that so that we can always change this and this become the value used in the code. So to do this, we use the memcopy function, which is a C function, but the BlueNRG stack has created its own version of this function. Okay, so I'm gonna come over here and then I'll say BlueNRG underscore memcopy. Memcopy is used to copy like one array to another. And then the first argument is the destination. So the destination is BD address over here. The next argument is the source. This is the source. And the last argument is the size. So we can use the size of function. So we simply say size of BD address here. Okay. So now we would have our device address in this local array here. Okay, so we're going to make use of this later. Also, we're going to create handles to hold the service. We're going to create a handle for the service, a handle for the device name characteristic, and a handle for the appearance characteristic. Handles in our BlueNRG stack is of type uint16. So create uint16 underscore t over here. And I'll simply say service handle. And then I'll say device name char handle, and then I'll say appearance handle or appearance characteristic handle. These characteristics are part of the gap service, the default or the compulsory gap service that we need to add. Okay, so I've created these. Next, we said we're going to initialize HCI. To initialize HCI, we simply call the HCI init function. So I'll say HCI underscore init. And for now, we're going to pass null and null. Later on, we shall investigate this function when we start to pass arguments to it. Next, we're going to reset HCI. To reset, we say HCI underscore reset. Okay, and we can delay for a while. We can wait for a while. Wait a bit. So I'll call our HAL delay function. I'll say HAL underscore delay. Then I'm going to pass 100 milliseconds here. Okay, so once we've done that, we said we're going to configure the device address. To configure the device address, we use a function known as ACI HAL write config data. We simply want to write config data. So to do this, like I said, we're going to use the write config data function. This function here takes 3 arguments. The first argument is an offset in the data structure, and then the next argument is the length of the data to be written, and then the third argument is the actual data. And this function writes a value to the low level the low level part of the stack for us. So this function is for writing to the low layer. So the offset here is 0. This is defined for us. The public address length, the second argument, what we want to write is the public address length. This is 6. And then the actual data, which is the device address, which is the public address, we pass it here. Right. Now, we can use these values, but this makes our code not too readable. We can use the defined constant for this value. So this offset value is actually defined in our blue nrg hal.c file or hal.h file. In one of them, we can use the value config data. It should be all caps. So I'll say we can use config underscore data public address offset. So this value is set for us. And then we can also come here and use public address length, which is also defined for us. So I'll say config underscore data pub addr underscore length. Okay, let's find these. When I highlight this, you see it's telling me its value is 0x00. When I highlight this, it's telling me its value is 6. I'll double click, right click, open declaration. And as you can see, we have over here Bluetooth public address offset. So the offset we have to use for public address is 0x00, or we can use its symbolic name that it is given. And how about Bluetooth public address length? Let's double click, go to declaration. The value here is 6. Okay, so this is defined in blue nrg1 underscore hal.h file for us. Okay, so we're looking good. Next, we said we're going to initialize the GATT server. So we have to initialize the GATT server. If we don't initialize this server, of course, nothing is going to work. The GATT channels won't process any command, even if we open a connection. Okay, and this, we have to do this before using any of the features of the GAP. Okay, so I'll come over here. The function we need to use here is ACI underscore GATT underscore init, like this. Okay, once this is done, we're going to initialize the GAP service, the compulsory GAP service. Okay, so we said we were going to make use of our printf. So what we can do is all of these functions, they return something. You see, this function returns a BLE status type. So we're going to say store the return value into our ret variable here. And over here, we can come here and say if ret is not equal if this is not equal to something like success, so there's a value here called BLE success that the library provides for us. I'll say BLE status underscore success. So if this is not successful, we can print something. I'll say printf, and then we can say, we can call the function, the name of the function, which is this over here. Failed. And then we can say new line encourage return, like this. Okay, let's see. Get init also returns status, so we can just say the same thing here. So we say ret, and then the name of the function is ACI get init. Okay, so we only get this printed when it wasn't, if it's not successful. Yeah, so next we're going to initialize the gap like we said. So let's deal with that. So later on, when we start building our own services and characteristics, you would see that we would have to explicitly add characteristics or create them. Over here in the compulsory gap service that we need to add, remember it's got the device name characteristic and the appearance characteristic, which we've created handles here to store their handles. These characteristics, we need not create them, we need not add them. In fact, they will be added by default for us. We just need to provide the variable to store the handles for these characteristics. So then our function for initializing gap takes a number of arguments, and two of these arguments are the variables to store the appearance characteristic handle and the device name characteristic handle, as well as to store the handle for the gap service. Okay, so the first argument of this function here is the role of the device. So our device is a peripheral, so we're going to pass peripheral role here. So I'm going to say gap underscore peripheral underscore role. The next argument is whether we want to enable privacy or not. So we can pass 0 to say no, or 1. So I'm going to pass 0 here. The third argument is the length of the device name characteristic. I'm going to pass 0x07 here. The third argument is the variable, an address of a variable to hold the service handle. So we created this variable here, service handle. I'm going to pass it address by placing ampersand here. The next argument after this is the variable to hold the device name characteristic. I'll copy this and then pass this over here. And then the last argument is the variable to hold the appearance characteristic handle. Okay, these are the handles. When I said device name characteristic, I meant to say device name characteristic handle, because these characteristics will be created and their handles will be returned, and we want to store them here. Okay. Next, we said we're going to update characteristics. So what we want to do is update the device name characteristic with the name that we've created here. We want to take this and give it and store it at the device name. Okay, so to update a characteristic, I'll change this update to be specific, device name. Okay, so we have to use the update characteristic value function. First include the word value here. So update characteristic value. The first argument here is the service whose characteristic value you want to update, and the name of the service or the service handle we've stored in our service handle variable. Okay. And the second argument is the handle So the first argument, the handle for the service whose characteristic you want to update. The second argument is the handle for the characteristic you want to update. You want to update the device name characteristic. So we take its handle and pass as the second argument here. The third argument is the offset. So the third argument, the offset from which the attribute value has to be updated. Over here, we simply pass 0. Okay. Following that is the length of the value. So over here, we're going to compute the length of this name pointer here. I'll copy this, and then I'll use our string length function, strlen. Then I'll pass this here, and then finally the value we want to update it with, the new value we want to assign, the characteristic value, which is our name value here. I'll typecast this to uint8 underscore t pointer, and then I'll pass this here like this. Okay, so this is what we have. So we finished creating our gap service, and like we stated, the device name characteristic and the appearance characteristic is created automatically for us. We just needed to provide an empty variable to store the handle that is returned when it is created, and we use that handle here to update the name of the device. Okay, so next we shall create our own service. We shall add our custom service. So that's all there is for this lesson, and I will see you in the next lesson. Have a nice day.